All right. Hi guys, how are you? And it's day 3 of the new year, 3rd of January 2025. Okay, and glad to see you here. All right, look forward to seeing a lot more of you over the near future. As this time, uh, we'll talk about gravity. There's so many different things to talk about, so many different uh, areas that are all taught incorrectly. One of which is gravity. Gravity, there's only a few people on the planet that actually know what they're talking about. Anytime anybody says anti-gravity, you know they're either lying to you, trying to misinform you, or they just don't know anything. Okay, most cases they're stupid. All right. Anybody that thinks that anti-gravity can get you to fly are stupid. Anybody that's not stupid is saying that to either make sure they don't get shot themselves or to take you off the track, get you away from the truth. The truth about gravity is a pushing force. Okay, gravity and gravity push away from each other. That's why planets and suns and galaxies and solar systems don't merge together, because they all have gravity. So they're all pushing themselves apart. Just like, it's well, the easiest way to understand it is the first law of magnetism, which is opposites attract, likes repel. Okay? As gravity is the same or similar, is almost identical to magnetism, the first law of gravity is and should be the same as the first law of magnetism. Okay, and that is opposites attract, likes repel. The reason for that is, if you had anti-gravity, which is an opposite of gravity, you would attract yourself so fast to the earth, it would turn you into a pancake. It would totally destroy you, annihilate you. All right? And so anti-gravity is the opposite of gravity. Anybody that doesn't understand that is, again, stupid. Now, there's nothing wrong with calling you stupid. Everybody's stupid in one form or another, at one time or another. I've been stupid many, many times in my life. I was so stupid I lost little over $1 million in product last year in 2024. Okay, so, I was stupid. I believed that the government would help and help me get recycling off the ground. Yep, I was stupid. I believed the wrong thing. Same with gravity. People who believe that anti-gravity will get you to fly are stupid. Okay? The only other reason they would tell you that is to misinform you, lie to you, and to make sure you're not following the correct path. Okay? If you want to fly or levitate, you need gravity. Okay? To prove that to you, to make that work, of course, and to understand it, there's so many different ways to help you understand. You can go into electron shelving. You can go into the atom. The atom is, of course, a smaller version of the solar system, or a smaller version of a galaxy. Okay, or even a smaller version of the universe. Okay, almost everything is pushing away from each other in the universe. That's why the universe is expanding. Gravity pushes gravity. Okay, gravity attracts mass. Whether magnetic or non-magnetic mass, doesn't matter. It attracts mass. Mass attracts mass. That's been proven, forever. It's just the way it is. And, of course, anything magnetic will attract itself faster to a magnetic mass than anything else. Unless, of course, the magnets are so strong they can deflect. But you'd have to be on one pole or the other to do that. Okay, you'd never do that in the middle. So on our planet, which we have a pole, north and south, okay, you have a magnetic mass. But it is... how do you say, gravity is omnipresent. It's everywhere. It's the same. Gravity's on the North Pole, South Pole, all the same. Okay, it's universal right around the planet. Gravity, we call it 1G. Of course, if you want to levitate and stay on the planet, you're going to need far, far less than 1G to do that. Okay, gravity is not hard to make. Once you understand it's not anti-gravity. That's why they've been telling you for so long, oh, you need anti-gravity. If you go back through our history of making movies, and you go back to the first 2 movies that were done on flying saucers, okay, which is the one with Gort, I forgot the name of the movie now, one I've watched so many hundred times, where the guy comes to Earth, and Gort is the big robot computer, the big robot that's out there to annihilate everybody. Okay, and it looks after Klaatu. That's it. It tries to protect him. Okay. In that movie, which is one of the first to do flying saucers, it tells you that it is a gravitational vehicle. Not an anti-gravity vehicle, a gravitational vehicle. Now, the first 2, or maybe 1 or 2 more, of the first movies done on flying saucers tell you that. Okay, consciousness is a wonderful thing. But after that, every other movie from those movies on says anti-gravity. The reason why? So they can mislead you, take you away from the facts. Because gravity is so easy to make. Okay? We are taught right through school. And I remember the class, I forget which grade it was, but it was whether it was before I left Mount Isa or after I left Mount Isa. I left Mount Isa when I was 10, I think it was, and came to the Gold Coast. I started the Gold Coast in grade 7, mid-year of grade 7, and then went on to high school. Now I already knew by then that we were already talking science. I think it was must have been grade 6, or even grade 5. We were taught about the Earth and the magnetic field and gravitational field, and we were taught that okay, the Earth has gravity, and of course, if the Earth stopped spinning, we would lose our gravity. Something about that sort of makes sense, and it's sort of easy to understand. So you have this giant magnetic mass, okay, spinning giant magnetic mass, then circling the sun on a shelf, because it doesn't leave the shelf, it stays virtually the same distance all the time. It's on the same shelf, whether it's elliptical or not, doesn't matter, it's the same shelf and stays there. As we're flying through space at an enormous rate of knots, following the sun as it's flying through the galaxy, we are following through on our planetary shelf. Just like an electron shelf in atomic physics, we have a planetary shelf in our solar system. So every planet stays on their own shelf, does not move from one to the other, because that's their gravitational shelf. That is, we have an Earth shelf, Mars has a Mars shelf, Venus has a Venus shelf, and they stay there unless something really bad happens. All right, that is our shelf. Now, our shelf here on with this planet is our 1G shelf, because we call it Earth's gravity 1G. Okay, for simple reasons. That's how we designate the Earth's gravity, 1G. Now, of course, if you want to stay on this shelf, you need to have 1G to be on the shelf. All right. If you generate more than 1G, you will move to a different shelf. You have less than 1G, you'll move to a different shelf once you're in space. You won't leave the planet until you have 1G or more. But of course, when you do generate 1G, you will leave this planet so fast it'll make your head spin. Because opposites attract, likes repel. Have you ever played with magnets? All right, if you're playing with a standard ferrite magnet, yeah, you put 2 north poles together, let the magnets go and they will separate quite quickly. All right, if you've ever played with a neodymium magnet set, yeah, that multiplies so fast. If you're playing with some bigger neodymium magnets, first thing you want to do is make sure that you keep all your fingers away, because when you get opposites, opposites attract. If you have any piece of your body in between those two magnets, you are going to know about it big time. All right, it hurts. I've had my fingers pinched a couple of times. I know of people that have had their fingers crushed. Okay, you do not want to be in the middle between two neodymium magnets, even little ones. They hurt. Okay, big ones. I've seen some big magnets, neodymium magnets, and you'd almost die if you got stuck in between those two. But the magnets, like poles, repel, and you get neodymium magnets. You put the likes together. If you can even hold them close together, you're doing well. But you let go of them, and they will separate really, really quickly. Then turn around and attract again. So unless you're holding them in a device that will stop them from turning around, they will repel very, very quickly. But yes, like poles repel, gravity repels gravity. Anti-gravity attracts gravity, or vice versa. Either way, they're opposites. Okay, so if you are able to make gravity, which I'll tell you how simple that is in a minute, if you, by chance, make a gravitational field of 1G, which isn't hard to make, it's just hard to control. Because if you're anywhere near it, or you're on the vehicle that you've just done 1G with, you're going to leave this planet very, very quickly, at almost the speed of light. Because 1G will repel it from Earth at almost the speed of light. But the thing to remember with the gravitational vehicle is that by using gravity, you then are designated into a shelf around the sun. All right, 1G will get you to the 1G shelf. Now, Earth sits on that shelf. Now, if you've ever played with magnets that are rotating around a central magnet, those magnets that are on that shelf, just like electrons, if they're all on the same shelf, they will manipulate or will push themselves to be at opposites or designated around the shelf. So if you've got Earth over here and there's only one other device at 1G, it will be directly opposite Earth on the other side of the shelf. Okay, so you've got the sun in the middle, you've got Earth up here, and your vehicle is down here. Now, if there's already a couple of vehicles out there that have been lost due to people playing with them, and they launched them and they're doing 1G, they will also be on that shelf, which will then, of course, position themselves equidistant around that 1G shelf while they stay at 1G. If you believe it will come back to Earth, you're dead wrong. If you lose gravity, you'll spin off into space. You will not come back to Earth. You cannot use 1G or lack of 1G to reduce your power, your gravitational power. It will not bring you back to Earth because, once again, gravity repels gravity. So even if you have half a G, if you're outside Earth's influence, gravity will repel gravity. Just not quite as fast. 1G will move you faster away from Earth than half a G will. Okay, but it will not attract you to the sun, or will not attract you to Mars or Venus, because once again they're all gravitational vehicles, gravitational planets. They have gravity, so while you have your gravity turned on, you will not be attracted to any planet in our solar system. Okay, so you need to use gravity as a propulsion by repulsion. So as a propulsion by repulsion. You repel yourself from Earth, turn it off, and then coast the rest of the way using some other form of device to help you manipulate your way through space. You can, of course, in that case, possibly use gravity to repel yourself away from different stars or different planets to help manipulate. And you can, if you can create it, then use anti-gravity to attract yourself to someone else, okay, or to make a sort of tractor field. Okay, so the sci-fi with the attraction field, which you can go grab something and pull it in, okay, which is a giant electromagnetic force. Or it could be a gravitational, anti-gravity force. It will not be a gravitational force. All right, because gravity repels gravity. If that vehicle has gravity, it will repel itself from you. Of course, if it doesn't have, it's just a mass, yes, then gravity may attract. Now, to make gravity, very, very simple. All right, the thing we learnt at school, and almost everybody does, is Earth has gravity until you stop it from spinning. Okay, even if you go back through the Sumerian text, you will learn the same thing. So I found out gravity is only working on our planet while the magnetic mass is spinning. Big trick. Okay? A spinning magnetic mass. All mass, if you spin it and spin it fast enough, will make gravity. Have a look at the sun. Have a look at Jupiter. Okay? The gaseous planets. Or plasma planets. Plasma sun. There's no magnetic force there. They're just mass. Huge mass. And of course they're turning. They're spinning. So that's what gives them gravitational force. It's a spinning mass. Mass is the secret. You want to make a gravitational vehicle, one, you need mass. Doesn't matter how big the mass is, it just increases the rate of spin for how little mass you have. Of course, if it's a magnetic mass, you can make it go, or make it even stronger. You can make it easier to make gravity. Now, as I said, you don't want to make 1G, so you do not wind it up and go flat out straight away, because the device will leave you so quick you won't know what happened, and it will hurt a lot of people on the way out. So what you want to do is to slowly spin it up. Now, it'll take some time to get it to levitate as you slowly wind up the device. If you have a magnetic mass of, say, 10 kilo, even better, 100 kilo, so you can have, I've been working it out in my head. I've had a revelation only just before Christmas that to make a gravitational vehicle, like we've seen on quite a few of the so-called flying saucers or spaceships that have landed or crash landed on Earth, supposedly, that most of them have a lot of mass. There's a lot of debris, heavy stuff. If you see in the ancient, in the archaeology, where they think they found leftovers of vehicle or possible vehicles, they look like honeycomb, iron, crystalline structures that weigh a lot. Okay, so mass is the key. Now, the ship can be a stationary mass with a gravitational, or rather, should I say, a magnetic or electromagnetic mass spinning within it. Just like we have the core of the Earth spinning. Okay, it is a plasma core, it's not an iron core. It's a plasma core, and we'll talk about that later. There's a lot of different things that happen when you've got plasma, which a lot of scientists are only just really copping onto, just getting started with what happens in a plasma vortex, plasma field, as to how matter is made. But that's another story. Right now we're talking about gravity, and to make gravity, you need to turn a electromagnetic mass. Okay, it's not hard to make. It's just hard to work out how to spin it fast enough. Okay, a lot easier doing electromagnets than it is magnets, because a mass to spin a mass and to work out. Here we go again. Sorry, I forgot to keep the. You can see me, but I can't see you. Okay, I just got to punch this in. Sorry about this. I keep forgetting to keep moving the mouse on the computer to keep the screen going. Okay, because we've been out at 20 minutes now, so I must shut down 20 minutes after I start. Okay, and so yes, you need to turn the magnet or turn the electromagnet so you can have a rotating electromagnetic mass, which of course is not matter. Just got to configure it just slightly differently. But the rate of spin is the trick. Now we have this planet of ours, the planet Earth, has a 1G that we call it, gravitational field. Remember, it's a field. Gravity is a field. It's not a particle. No such thing as a graviton. That is a make-believe particle that some silly quantum idiot came up with to try and describe or try and come up with an answer to gravity. Okay, oh, must have particles. Yeah, a load of bullshit. Okay, that's the quantum idiots trying to brainwash everybody to get them away from the ether. Of course, the quantum version of ether, or the quantum understanding of ether, is a quantum field. No such thing as a quantum field. You can't quantize a field. Unless, of course, you come up with imaginary particles. Because without particles, you can't quantize anything. Okay? Light is not a quantizable event. Light is a electromagnetic beam. It's a field. It's a wave. There's no particles in light. You know, when you're looking at a torch or even a light bulb, it's the light we got up there. Okay, unless there's particles between that light and my screen, all this white stuff up here, you would not see. Okay, because you have to have something to reflect off, or for the energy to induce activity in, to create light, or create something we can see. Like from the sun to Earth. Get up there with the camera. If the guy's in space having a look, you can look at the sun. You can look to the side of the sun. Okay? You can see past the sun. If light was a particle, you wouldn't be able to see anything. Because light would be everywhere. Be omnipresent. Everything would be white. You wouldn't be able to see the hand in front of your face if light had particles. Because there's no way it could reflect to you. You wouldn't be able to see me if light was made out of particles. Okay? The beam or the wave, the energy wave we call light, has no particles. But it does excite particles. Because energy imparts energy into particles. Just like as I described in another video, the wave on the beach. Wave itself has no particles. Okay, but there are particles in the water, but it doesn't move particles until the wave strikes the beach. Then it stirs up all that sand and all that garbage that's on the beach. And all those particles all of a sudden have energy and are floating and spinning and jumping and all, they're going everywhere. If you've ever been in a dumper where you've been swimming on the surf and you got dumped on the shore, you'll know what I mean. You're a particle and the energy is just huge. It throws you around, slams you into the earth. It covers you in dirt. That is the energy imparting, or giving you, putting the energy into you, inducing the energy into the particle and making the particle become active, so you can then see it, feel it, whatever. All right, but waves, electromagnetic waves, light waves, ocean waves do not transport or do not have particles. They do impart energy into any particles that are in there, or in the ether that it's moving through, but energy waves do not have particles. Gravity is a wave. It is energy. It is not a particle. There's no such thing as a graviton. Go check it out with the guys who tell you about gravitons. Oh no, it's an imaginary particle that we put in there so we can work out what gravity is. You're an idiot, okay? So, gravity. All you need to do is spin a mass, preferably a magnetic mass, because it makes it easier. And of course, we have Earth, which is big. All right. If you want to make a 100 kilo mass have 1 g, or even 1/10 of a g, you need to bring down Earth's gravitational field and work out what you need to do and how fast you have to spin your mass to make, say, 1/10 of a g, which will still probably launch you off the Earth pretty quick. I don't know, I've never done it. I've planned on doing it this year, since I finally now understand that I need mass to make it work easier for me. Okay, very hard to do with something light. You want light for something light when you're using rocketry. Rocketry, the lighter it is, the easier it is for you to leave this planet. But when it comes to gravity, gravity requires mass. So you want to make gravity and make it easier, you need larger mass. Not necessarily larger spinning mass, but a larger mass to help you with that gravitational field once you make one. So you then have, for example, we use material to make it rather than electromagnetic. If you're using a material ball or material mass, magnetic mass that you're going to turn to make gravity, you have to work out how fast you need to turn it. Easiest way, of course, is to start turning it and just get it faster and faster and faster. But before you work that out, you need to make sure that your device is able to spin fast enough to be able to give you that 1/10 of gravity or 1/100th of gravity, which is awfully damn fast. So Earth has 1 g. Now it only has 1 g because it's spinning. We've got this giant mass the size of the Earth, which we know the weight of. I haven't got those figures with me right now. We need to spin that 1 revolution in 24 hours to make 1 g. All right, so if you want to make, say, well, let's just work on 1 g, to make 1 g, and you have a 100 kilo mass, you need to work out how many times 100 kilo goes into the weight of the planet, okay? And then multiply your revolutions by that number. So if you had another planet the same size as Earth, to get 1 g, you need to spin it, if it's the same mass, same magnetic mass as Earth, 1 turn every 24 hours will give you 1 g. If it's half the size, there's a good chance you need to go twice as fast, maybe 4 times as fast. Okay, to get 1/10 of a g, all right, as size of the Earth, you need to go travel at 1/10 the speed. But at 100 kilo, that's thousands of revolutions per minute, maybe tens of thousands, maybe 1,000 revolutions a second. I don't know. I haven't worked that one out. So easy for somebody with a little bit of mathematics. Remember, mathematics has nothing to do with whether you're working with etheric physics or quantum physics. Mathematics is just maths. Okay, it's multiplication table, division table, plus, minus, whatever field you're working in. Maths is just maths. It's universal. There is no one, oh, it's just one for quantum physics and another one for ether. Bullshit. It's the same thing. All right. That's why so many things that we do today are able to be worked out, and they call it quantum physics. But what they're doing and what they're working with is what we did 100 years ago, 120 years ago, 150, 1,000 years ago. which all they did, they all believed in the ether. They didn't know anything about quantum physics, but we're still using the same stuff today. We're still doing electricity. Okay, if we started doing quantum theory 200 years ago, we would not have electricity, because you can't work out electricity with quantum theory. Okay, you can't do it. Okay, it's all etheric. It's all energy in the ether. It's all about fields. Quanta does not manipulate or does not tell you or teach you about fields. Cannot do, will never do. Okay, quantum physics and quantum mechanics is all about particles and what they do. All right, we're drifting away again. We're into 30 minutes now. Guys, gravity is not hard. All you have to do is get away from the silly idiots that keep on trying to teach you it's anti-gravity. Anti-gravity sucks you into the earth so fast, you'll be dead in milliseconds. All right? If you want to levitate and want to fly, or want to leave the planet, you need gravity. After that, you may need rocketry or plasma devices, or whatever other device to help you propel you through space. But to get you off Earth, you need gravity. Okay. Thanks, guys. Thanks for sticking with me. Talk to you again soon. Love yous. Bye.